Concept 24B, teacher talk. In examples 1 and 2, show the triangles are similar and explain how. Then write a similarity statement. Looking at number 1, I always say, what is given information from the picture or from the text? Well, given in this, I can see that I have a congruent angle. X is congruent to itself. I don't know any other information about the angles, so now I need to look at side lengths. They've given me some measurements, so let's check to see if they're proportional. So 15 over 35, is that equal to 27 over 63? Yes, it is. So if my sides are proportional with an angle in between them, I know I have side angle side similarity. And my statement would read WXY is similar to VXZ. And there's a couple different combinations of those letters you can use for your similarity statement. Looking at number 2, I don't have any information about angles, no angles. So I must rely solely on the sides. So that should scream to you side, side, side similarity. But we got to check and make sure. So let's put some work down. 7, comparing it, you can see my colors green and green. 7 divided by 10.5. That's supposed to be equal to 12 divided by 18, which is also supposed to be equal to 8 divided by 12. Plug them in your calculator. Check, check. Those do work. So because all of our sides are proportional, I know these two triangles are similar by side, side, side similarity. So when I write that similarity statement, triangle LMN is similar to triangle RQP. And lastly, number 3, a flagpole. So in order to estimate the height h of a flagpole, a 5-foot tall male student stands so that the tip of his shadow coincides with the tip of the flagpole's shadow. This scenario results in 2 similar triangles, as shown in the diagram. We've got 3 parts, A, B, and C. A, why are the 2 overlapping triangles similar? Well, let's take a look. I notice that I have angle A. It's congruent in both triangles. It's the same angle. And I also notice that the flagpole's got a right angle, 90-degree angle with the ground. And if I'm standing straight up and down, I've got a 90-degree angle with the ground as well. So that screams to me angle similarity. Got right angles, 2 right angles, triangle, and the same angle A in both triangles. Part B, using the similar triangles, write a proportion that models the situation. So remember, we need to go from the numerator and the denominator. Need to go from small triangle to big triangle as we go from fraction to fraction. So I'm going to look at 6. Well, what compares with 6? It's got to be 12. We need the whole entire thing. That's going to give me 18. I don't know why I just wrote that. I wrote it already. Alright. And I need my other triangle. My other fraction. So I've got 5 for the height of the person. What corresponds to that? And what are we trying to find? Height of the flagpole. And 18 was on the denominator, so height needs to go on the denominator here. That's a bad looking H, but it is an H. And part C says, what is the height? We need to solve by cross multiplying, so we get 6H is equal to 90. 90 divided by 6 gives you 15. 15 feet.